Thanks for coming back. Today we're going to be working on section 13.3 on trigonometric functions of any angle. We're going to start with the general definition of trigonometric functions. Some books call this the point in a plane description of trigonometric functions. Let theta be an angle in standard position and xy be any point except the origin on the terminal side of theta. The six trigonometric functions of theta are defined as follows. Sine of theta is y over r. Cosine of theta is x over r. Tangent of theta is y over x, with x not being equal to 0 because you can't divide by 0. And then the cosecant of theta is r over y. That would be the reciprocal of sine. The secant of theta is r over x. Secant is reciprocal of cosine. And cotangent of theta is x over y. And cotangent of theta is the reciprocal of the tangent of theta. What you do need to notice in this definition is that you're in standard position and that x and y is any point except the origin. You also have to watch down here with the cosecant and the secant and the cotangent that with cosecant y cannot be 0, so you can't be on the x-axis. For secant of theta, x cannot be 0, so you can't be on the y-axis. And cotangent of theta, y cannot be 0, so you can't be on the x-axis. So let's try a problem. Let negative 8, 6 be a point on the terminal side of an angle theta in standard position. Evaluate the six trig functions of theta. I am going to first just sketch negative 8, 6. So negative 8, 6 is right here. There's my ordered pair. And I also need to know what r is. And r is this line from the origin to the point, the segment from the origin to the point. I'm going to use the Pythagorean theorem to figure out what r is equal to. So a squared plus b squared is equal to the hypotenuse squared. So 64 plus 36 is equal to c squared. C squared is 100, so that would mean that c is equal to 10. So I have everything that I need. I know x, I know y, and I know r. So the sine of theta is equal to y over r. So that would be 6 over 10. And then we can simplify that. That would be 3/5. The cosine of theta is x over r. So negative 8 over 10. And again, simplify this. Negative 4/5. And the tangent of theta is y over x. So that's going to be 6 over negative 8, which is negative 3/4. I also want you to notice with the tangent of theta, when you do y over x, that's also the slope of this segment right here. So tangent is slope. Then I can do my reciprocal functions. The cosecant of theta is a reciprocal of sine. The secant of theta is the reciprocal of cosine. And the cotangent of theta is the reciprocal of the tangent. Be careful of your positives and negatives. You want to remember that when you're in the coordinate plane, your sine in the first quadrant is greater than 0, your cosine is less than 0, and your cosine is greater than 0, and your tangent of theta is also greater than 0. So in the second quadrant, your sine is positive, the cosine is negative, and your tangent is negative. Remember, the sine is your y over r, so it's going to be, r is always positive because it's a distance. And y in the second quadrant is positive, x in the second quadrant is negative, and tangent, besides thinking of it like y over x, it's also sine over cosine. So if you take a positive divided by a negative, you get a negative. In your third quadrant, your sine is negative, your cosine is negative, which makes your tangent positive. And in your fourth quadrant, sine is negative, cosine is positive, tangent is negative. Now for some vocabulary. A quadrantal angle. A quadrantal angle is an angle where the terminal side of theta lies on the x-axis. This is a fancy way to say that your terminal side is either your positive y-axis, your negative x-axis, your negative y-axis, or your positive x-axis. So it is just these. So even though this doesn't look like an angle, what you want to remember is that in trig, our angles are made up of two rays. You have your initial side and you have your terminal side. So this would be an angle of 0. This would also, if the side, the ray gets rotated all the way around, this would also be 360 degrees, or if you're in radians, it would be 2 pi radians. This is a positive 90 degrees, or pi over 2 radians. This is a quadrantal angle, it's 180 degrees, or pi radians. If I had gone this way, then it would have been negative 180 degrees, or negative pi radians. Here's a 270 degree angle, this is also a quadrantal angle, or 3 pi over 2 radians. So we're going to evaluate the 6 trig functions of theta at 360 degrees. So here is my picture. That's 360 degrees. So this is my initial side. It's also my terminal side. So I'm going to refer back to that general definition of trigonometric functions. And I'll start with sine. So sine of theta is equal to y over r. Now, it doesn't matter where I am here. If it's y over r, my y is always 0, and my r is always some positive number. So my sine would have to be 0. My cosine is going to be x over r. So wherever I am on this axis, x and r are going to be the same number. Exactly the same number. So any number over itself will give me 1. The tangent of theta is y over r. So if I think of it as y over r, y is going to be 0 anywhere on this positive x-axis, and r would be positive, so I'm going to have 0. Or I could also think of it as tangent is sine over cosine, so 0 divided by 1 is 0. Then my other functions, I have my cosecant theta, which is the reciprocal of sine, and this is 0 over something. If I do a reciprocal, I'll be dividing by 0. So I can't find a value for cosecant, so this is undefined. And that's what you say. You say the cosecant of theta at 360 degrees is undefined. That's the word that you use, undefined. The secant of theta is the reciprocal of cosine. So that's going to be 1, because 1 over 1 is the same thing as 1 over 1. The tangent is 0, so that means the cotangent of theta is also going to be undefined, for the same reason that it is undefined up in cosecant. You cannot divide by 0.